coin will be tossed twice. Let E be the event, the first toss shows heads, and F the event, the second toss shows heads. Are the events E and F independent? Well, two events are independent if the occurrence of the first event does not affect the probability of occurrence of the second event. And the way we express that mathematically is if the probability of F, the second event, is the same as the probability of F given that E has already occurred. So if E happens, that doesn't change the probability of F. And that certainly is the case here, because the probability of the second heads, so the probability of F, is 1/2, and the probability of getting heads given that the first coin toss was heads is still 1/2. So these are the same and therefore they're independent. Another way to think about it is if you have one coin that's tossed twice, there's no memory. The coin doesn't have memory of what the previous coin tosses were. So every single time you toss the coin, the probability is always 1/2 for heads and 1/2 for tails. They're always independent tosses. So yes, these are independent. Then find the probability of showing heads on both tosses. So the probability of heads on the first and heads on the second, that's the same thing as the concept of both. But when we put and in between our probabilities, that tells us that we need to multiply the individual probabilities. So it's the probability of getting heads, which is 1/2, times the probability of getting heads on the second toss, which is still 1/2 because these events are independent. So that is 1/4 or 0.25.